Hello students, today we are covering section 7.2, part B, add and subtract rational expressions. By the end of the first half of this section, you will be able to add and subtract rational expressions with a common denominator. You'll also be able to add and subtract rational expressions whose denominators are opposites. You'll add and subtract rational expressions with unlike denominators, and you'll add and subtract rational functions. These rules will help you remember the steps for adding and subtracting fractions. First, you find the least common denominator, the LCD of the fractions. Then you'll express each fraction as an equivalent fraction. We've been practicing that. With the LCD as the denominator. So we practiced these two steps in our last section that we covered in our last class. And then the only thing we have to do from there is to add or subtract, but then we have to simplify. All right, so adding and subtracting with a common denominator is pretty easy. So we have 4/15 plus 13/15 minus 7/15. And that will equal 17 minus 7, 10/15. And then we can simplify that to 2/3 because we can divide by 5. Right, what if it is an algebraic expression? Then we still do the same thing. The denominators are the same. It's x plus 2. So then our answer will have x plus 2. Let's look at the common or the like terms. And we're subtracting. So 3x squared minus x squared is 2x squared. Then we have -8 minus -9. Remember that we have to change that to plus plus, right? -8 plus 9, that's a minus, a negative is plus. -8 plus 9 is positive 1. And we cannot simplify that any further. You can't cancel out x's, you can't cancel out 2's because they're being added. If you need me to show you why, to prove it to you, I am certainly happy to by just plugging in a number for x, and you'll see that it can't cancel. All right, for this next example, we have unlike denominators, so we need to find a common denominator, which we were practicing in our last class. We have 42 and 18. I'll do the tree method over here. 42 is 6 times 7. 18 is 6 times 3. And even though the 6 is not prime, since they're the same, we're going to use that. And then the 3 and the 7 are prime. So our LCD is 6 times 7 times 3. 7 times 3 is 21. 21 times 6 is 126. So that is, and then we had a common denominator, or I mean not a common denominator, a denominator of 1 in the 2. So we'll put 126 plus 126 minus 126. Okay. So what would we multiply 42 by to get 126? It's going to be that extra number that we had over here with the 18, right? So the 42 is 6 times 7. If we multiply 6 times 7 times 3, we get 126. So I'm going to multiply this by 3/3. And 25 times 3 is 75. Then to get 18, to become 42? Well, it's 6 times 3 times 7. And so 11 times 7 is 77. And there we go. Then to get the 2, or what we do with the 2, 1 times 126 gives us 126. So we have to multiply the 2 by 126. And that will be, let me see, 252. Okay. And then I will add the 75 and the 76. And actually what you can do, and this might be helpful, is you can write the denominator and then you can write all of the numerators in one numerator all together in one. This would be where I might use a calculator if I had one. I'm going to add these first. 152, awesome, because that 152 minus 252 is negative 100 over 126, and that simplifies to 63 and 50 if I divide by 2. And I think that is as far as it simplifies. Don't forget your negative, I almost did. So that is our final answer. In this example, we will add and subtract rational expressions with unlike denominators. And we also have variables. So what would we multiply if we have 2x and 3? What would our least common denominator be? Yeah, I don't really have to do a tree for this. I can see it's going to be 6x. All right, to make 2x into 6x, I multiply by 3, so I also have to multiply the 5 by 3. That's 15. And then to get 3 to become 6x, I multiply by 2x. 2 times 2x is 4x. This equals 4x plus 15 over 6x. See if you can do B in your groups, and then we'll come back and we'll do C together. In this case, we're going to need to use some factoring to be able to find the LCD. All right. Just going to rewrite this as 1 over the difference of squares, x minus 3, x plus 3. That's coming from the x squared minus 9, plus 2 over, this one we can just factor out an x so that we have x plus 3. Now we do not want to start canceling things out. Some people learned, when we learned the multiplication and division, that we cancel factors out if they're the same. This is not the case because we don't have it in the numerator, we only have it in the denominator, and we want the denominator to be the least common denominator. So we're actually going to use that x plus 3 as part of our LCD. Okay. So our LCD is going to be x minus 3 and x plus 3, and we're going to add an x. And that's coming from what we have here. We have an x minus 3. Those are the same. But what we have that's different is the x and the x minus 3. So we have to put all of them together so that we have a common denominator. Now, we will rewrite this with the common denominator as x, x minus 3, x plus 3, plus, and we write that common denominator again. So to get the 1 right here, or what we need to do with the 1, is we have to multiply by x so that the denominator has the extra x. So 1 times x is x. And then on the second term, we have x, parentheses x plus 3. We also need an x minus 3 to have a common denominator. So we multiply the numerator and the denominator by x minus 3. So then we have 2x minus 3. To be able to add and simplify here, we have to distribute that 2 out. I didn't make you do that on our last class because it wasn't necessary for what we were doing, but we are going to distribute out here. So then our common denominator is x, x minus 3, x plus 3. Then we had our first x plus, here we distribute, we have 2x, and 2 times negative 3 is negative 6. We can combine like terms, x plus 2x is 3x, so 3x minus 6. And if you want, you can distribute out the denominator, but I am also okay with you leaving it the same. Except that I'm wondering, no, nothing would cancel out. If we refactored the 3x minus 6 into 3 parentheses x minus 2, I'm going to just show that over here. So, or it could also equal 3x minus 2, but nothing cancels. We want to just check that because if it does cancel, we want to cancel it. That's how we would simplify our rational expression. Get ready to turn your page. And let's look at B. And I want you to look at these denominators. Are they the same denominator? No, they're opposites. So I want you to write that. And what are we going to do with that? Well, we could, see if you can follow this, we can change it to just adding instead of subtracting, and then that would make this flip-flop. All right, let me explain that. If we factor out a negative 1 here, then it becomes 5 minus a. But a negative times a negative is a positive, so that's why I'm changing it, and I said that you can just change it to adding, right? Is a minus times a minus is a positive. So we end up having a double negative. Now the denominators are the same, and that's really simple. We just get 6 over 5 minus a. For example C, we're going to need to use some factoring, and same thing for example D. I would like us to try those in our groups. Let's do C in our groups, and then I'll finish the video for D. All right, let's factor these